Question 1. The period of vertical oscillation of mass hanging from spring is shown to be constant. It is known to be constant. A student times single oscillation with stopwatch in 10 separate measurements. The stopwatch readings were 1.8 second, 1.9 second, 1.7 second, like this. What is the best value obtained from these readings for time of one oscillation? Basically, they are asking what is the um, time period. You see, we can find out the mean of this. Okay. So 1.8. There are two methods we can follow actually. We can find out the mean, which is 1.8 plus 1.9 plus 1.7 plus 1.9 plus 1.8 plus 1.8 plus 1.9 plus 1.7 plus 1.8 plus 1.8 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. We get mean to be 1.81. Okay, seconds. So explanation will be you'll add all of them divided by the number of oscillations. Okay, this is one explanation. Otherwise, there is another method. You can find out the mode. Mode is most repeated reading. As you can see, 1.8 is repeating 1, 2, 3, 4, 5 times. However, 1.9 is repeating 3 times, 1.7 is repeating 2 times. Okay, so 1.8 is mode because it is most repeating number. Okay, that's why you can also choose that 1 point is the best value. The explanation will be obviously most repeated value. You'll write. Okay, which is nothing but mode. Okay, so these are two ways to answer this question. Describe how using the same stoppers the student can find the period of oscillation more accurately. Okay. So you see here the student has individually found out the time period of oscillation for one oscillation. Now, in order to improve the accuracy, what you can do is you can find out time for 10 oscillation, T10 let us consider, or maybe 20 oscillation that will increase. I mean, you are increasing the sample number or sample size. So margin of error will decrease. Okay. So find out the oscillation for 20 oscillations. Okay. Find out the time for 20 oscillation, not individually, the whole 20 oscillation. You will start the stopwatch when the oscillation is starting. After 20 oscillation, you'll immediately switch the uh, timer off. Okay, you'll note down the reading. Again, you do the repeat the experiment 20 oscillation. You note down another reading, another reading, another reading, another reading, like this 5 times. You can do it and write down the oscillation. I mean time for 20 oscillation. Now you can find out the time period for each reading. How? T20 divided by 20, you'll find out the time period for each oscillation. You'll note it down here. Same thing you'll do for this one, this one, this one, this one, like this. Now what you can do? You can take the average of all this time period. Okay, 1, 2, 3, 4, 5. So you'll add all this 5 and divide by the 5. You'll get a reading which will be more accurate because the sample size is now huge. Here you have only taken 10 oscillation, that too individually. You are taking 20 oscillation each time. So 20, 20, 20, 20, 20. So 100 you have taken, 100 sample size you have taken. Then you are taking average individually, and then then taking, finding out time period for each oscillation 5 times and then averaging it. So margin of error will drastically decrease. This is how we can find out more accurate value of oscillation. Sorry, more accurate value of time period of oscillation. Okay. Now, if you may want to make it more accurate, you'll also have to, while doing the experiment, you'll also have to make sure that you fix zero error. You'll have to see whether the zero error is there or not. If it is there, then improve the zero error. Do I mean you can remove all the systematic errors possible. Instead of you switching on the timer, you can make sure that that a laser falls on the pendulum. When it starts oscillating, the timer starts automatically, and after 20 oscillation, it when it reaches this point after completing 20 oscillation, immediately the stopwatch stops. Okay. In this process, you are reducing the systematic error by a huge amount. Okay. Or human error by a huge amount. Okay. So in this process, you can make um, the reading that you are getting more reliable with very less margin of error, or accuracy you can improve like this.